After completing this lesson, you will be able to understand structural floors, create a one-way and two-way spanning floor, create a sloping floor, attach walls to a floor, and add a slab edge. The objective domains covered are 1.1b, work with structural floors, and 1.1c, work with structural walls, attaching a wall to a floor. A structural floor has load-bearing capability and is usually positioned horizontally within buildings. Revit has two implementations of a floor. An architectural floor can be converted to a structural floor. This type of floor will normally contain the finishes and the compound layers. A structural floor can be converted to an architectural floor. This type of floor will be used for load-bearing applications and structural analysis. A slab that is supported on its two longer sides is said to be a one-way spanning slab. The one-way spanning slab is designed only to resist bending moments in the short axes, and hence the main reinforcement is placed within this axis. A one-way spanning slab will typically be composite and have corrugated structural steel deck applied. The two-way spanning slabs will bend in both directions and will need moment-resisting reinforcement in both axes. A slab edge can be applied to a floor or foundation slab. It is typically applied to the edges of a floor and can create an edge for a raft foundation or upstands or downstands. It should be noted that a slab edge does not contain an analytical model, so careful consideration needs to be applied. An alternative to a slab edge is to utilize structural framing or a structural wall. Go ahead and open up the file 008 Work with Structural Floors Part 1. You'll notice that this model opens up in the 00 ground floor plan. Our first task is to draw a two-way spanning slab in this area of the structure. To begin, let's select the structure ribbon and then the floor. You'll currently notice we're in the boundary line mode. We have three modes when working with floors. Boundary line, which is where we draw our planned shape of our slab. Slope arrow, which is where we can define a slope or a fall in one direction. Or a span direction, which is how we can define a one-way or a two-way spanning slab. Let's go back to the boundary line mode and make sure we've selected line. In the Properties palette, let's ensure that we've selected the RC slab 12-inch. As I start to draw my boundary, I require an 18-inch offset from the grid line. You'll notice on the options bar, we have the facility of adding in an offset. I can then begin to draw my slab. It's important that I draw in a clockwise direction. This will ensure that the offset comes out on the correct side. I can now switch to Start End Radius Arc and then return back to line. Clear my offset and set that to 0, and then finalize the shape of the slab. In this example, the span direction doesn't matter, but you can see here that we have a span direction symbol. If I wanted to, I could pick on span direction and I could select another edge. In the Properties palette, you'll note here that we have a height offset from level. So what this is going to do is place the slab at the level ground floor with an additional 6-inch offset. We want this to be on the level, so we'll set that to 0. We can then go ahead and select the Finish Edit mode. Your slab is now created. Let's look in the 3D view and check our model. Next, we model our one-way spanning composite deck. To do this, let's open up the 01 first floor plan. You'll note here that we have some steel beams that are going to support our deck. And we'll begin by clicking the structure ribbon and then selecting floor. Let's ensure that in the type selector we have selected our RC composite slab 8 inch. Now before we go ahead and use this, let's take a moment to look at the build-up of this composite slab. Go ahead and select Edit Type, and then select Edit. You'll note here that we have our preview showing. If the preview is not showing, you can use this button in the bottom left of the dialog box just to show the preview of our assembly. And you'll note here that we have two layers. We have our main structural layer over here, which is our normal weight concrete, 8 inches thick. And we then also have a structural deck underneath that. The structural deck is simply a profile family. Here are the different profiles loaded into this particular project, but of course we could download a new profile or simply draw our own profile. It has to be noted that the structural deck will not be modelled in 3D. This is simply a two-dimensional detail that we'll see in section or elevation. Let's go ahead and click OK to the Edit Assembly dialog box, and OK again to the Type Properties dialog. We're now ready to create our boundary for our slab. Now the boundary we create is going to be a rectangular boundary representing the steel deck. So on the Draw tools, let's select Rectangle. We'll trace off the grid lines. And now we want to create a cantilever. So let's go ahead and select those boundary lines that we've just created. And on the options bar, you'll notice here that we have concrete cantilevers. So here I want to achieve a 6 inch cantilever. So I'm going to put in negative 6 inches. And you'll now notice that we have a black boundary line going around the outside of the structure. So this is going to be my plain concrete that cantilevers beyond the deck. In the properties palette, again, ensure that your height offset from level is set to 0. We can now go ahead and complete the deck. Let's click the Finish Edit mode. To help us understand what we've modelled, we'll create a section through our floor. On the Quick Access toolbar, click the Section tool and create a section through your floor slab. We can then go ahead and look at that section. I'll set my scale to something appropriate and the detail level to fine. And we can now see our floor. We'll note the steel deck is showing in 2 dimensions and we have our concrete cantilever over the edge of the steel deck. Next, we create a sloping floor slab. In the project browser, open up the plan 05 5th floor. Here, we're going to create a slab on top of the core with a 6-degree fall. To do this, on the structure ribbon, select floor. Let's ensure here that we're using our 6 inch concrete slab. On the context ribbon, note we're in the boundary line mode, and here we're going to utilize Pick Walls. On the options bar, note that we have a 1 foot offset. I can then simply go around and pick the boundary of my walls, and then I can go to Slope Arrow. Now here, I would like to pick the line that's going to determine my slope. So that's going to be this line here. The height offset at tail is going to be set to 0. I want to actually specify a slope. So here I can put in 6 degrees. And now we can go ahead and finish edit mode. Now Revit does ask me if I want to attach the walls to the underside of its floor. Normally I would click yes, but I want to show you how to do this using some other tools. So let's select no, and then open up the 3D view. You'll now notice our walls and our slab. So we're then going to select all of our structural walls and attach them to the floor. To do this, let's select the walls with a crossing window. Up on the context ribbon, you'll note we have Modify Walls. Here, we're going to attach top base. On the options bar, I can determine whether I'm attaching the top of the wall or the base of the wall. In this case, it's the top of the wall, and we can then simply select our floor. The walls are now attached. If the slab changes angle, then the walls will adapt. So I'm going to select the slab, and note here we have our 6-degree pitch. Let's change that to 12. And of course, we can see all of those walls adapt. Finally, we create a slab edge. In the 3D view, you'll note here that we have our original ground floor slab that we created. On the structure ribbon, select the floor drop-down and select floor slab edge. In the properties palette, select edit type. And you'll note here that we're using this particular profile. I'm going to change this to a slab edge thickened 36 by 12. And here we have our material. We'll then rename our slab edge, and I'll just amend the 24 inch to 36 inch and select OK and OK again. We can then simply select the edges where we want to apply our slab edge. You'll notice that we have an inbuilt flip tool where we can actually flip the profile of the slab edge if it was in the incorrect position. Let's switch to our ground floor plan. To help us understand what we've modelled, we'll create a section through our slab edge. Again, we can go ahead and change the scale and the detail level. And there's our slab edge. The slab edge will stay associated to the edge of our floor, so if the floor boundary changes, the slab edge will follow.